Hello, Paul Beckwith again, and I'm talking all about the Arctic sea ice and how long I think it will stick around given the behavior of the sea ice extent and the volume and the spatial variation of Arctic sea ice in the Arctic Ocean. So there's lots more information on the Arctic sea ice, so I'll get right into it, continue my discussions on it. And this is a learning process for us all. We just don't know. This year, the behavior of the ice surprised a lot of people, as it was flattening out here. That was quite unexpected. So I've sent out a lot of tweets. Go to at Paul H. Beckwith to have a look at them. Okay, so this was Zach Laib's post showing the sea ice age over time, and I discussed that previously. Now, this is this image shows, this is 2019. This is the minimums in different years. So 2012 was the lowest, set the record. The lowest sea ice extent occurred, I guess it was September 16th of 2012. 2007 was a very low year. 2016, beat out 2007, but was nowhere near 2012. And there's some scatter, sometimes it's the first week of September, sometimes usually it's about mid-September, but there are cases where it runs towards the end of September. Like 2018 was fairly late date of the minimum. Here we were coming down this way, and we were tracking 2012, and then we kind of flattened out across here, and then we dipped down a bit, and then we flattened out. So we're going to be somewhere near these regions here. Maybe I think we're just second right now, maybe second or third even. Okay, so that gives you an idea of where the minimums are. This is an interesting plot showing the Arctic sea ice extent, the daily change. Okay. Now Zach was saying, as a result of the recent shift, this is August 26th, to colder and stormy weather, the rate of Arctic sea ice loss dramatically slowed. Although I didn't see that we went to colder and stormy weather really that much, but so this is called a century loss of over 100,000 square kilometers in one day. So this is gain of sea ice. This is loss. It's interesting to see that some days there's actually a loss of extent. And this depends if the winds compact the extent, or if there's a lot of export out the Fram Strait or something. A couple lost days here, but this is through the winter. The extent is growing. It does have some huge growth days, but not as many as huge loss days. And then these are the losses here. This is for 2019. So it's really tapered off here. And, this only goes to sort of, mid-August, but it really slowed down and tapered off extremely quickly, causing the extent to flatten out like this. Okay, so really interesting portrayal of the data. This is, of course, global surface temperatures overall. We had super El Ninos here, super El Nino here. This is relative to the 1880 to 1920 mean. So you can see, we were pushing up with this super El Nino, 1.3, 1.35 degrees above this particular mean. And if you want to go to above pre-industrial, 1750, you need to add at least 0.3 on here. So we were, that gives us up to 1.65, well above the 1.5 comfort window. Okay, this is interesting. The best linear fit here, 0.18 degrees Celsius per decade. You need to double or triple that to have the decadal rise in the Arctic because of Arctic amplification. Really neat plots here from Zach. So this is specific humidity. This is grams of water held per kilogram of air as a function of elevation. We have the Antarctic here, Arctic here, and you can see, as the sun shifts, the peak of the water vapor goes. It's interesting, you can also see some spikes here coming up, appearing in the data. So I'll have to look at this more closely. See the spikes coming up here? Very interesting. This is the Arctic sea ice extent with the remarkable stall. We were tracking below 2012 and then above, and we really just flattened out again. Incredible stall. Zach was saying, it's a shift in the large-scale circulation pattern and the spatial distribution of the ice. Okay, so this is the average summer 2019 temperatures at 925 hexapascals. So not at the surface, but not quite a kilometer above the surface. And what you can see is it ties with the 2007 number. Okay, so hot at the surface, also hot going up into the atmosphere. This is air temperatures throughout. Again, we have pressure here, so we're going up in elevation here, and then the temperature here near the equator, this is 0 to 30 Celsius. You can see the shift with the seasons. Again, these things are very mesmerizing. There's lots of information in them. Air temperature rank by month. So this is 2019 here. Okay, so you can see the how warm we're getting here. This was in 2016. Some records here. 2016, very, very warm year, strong El Nino year, set all kinds of records. Right, we're not in a strong El Nino, and we're still, we're setting these records. Okay, of course, sea levels rising, 3.37 millimeters per year is the latest. This is sea surface temperature through the years. Okay, so you can click it to stop it at any given year, and you can see the patterns. Look what happens when we go up into the 2000s. Okay, red everywhere, in the northern hemisphere. So extremely warm temperatures. I didn't want it to restart. Okay. Anyway, there's a hole here, and very, very warm temperatures here. So it looks like the Gulf Stream. I'll let it go to 2019 and stop. Okay, so extremely warm temperatures over here where the blob is, and the Gulf Stream is slowing down, getting stuck over here. Very warm here. It's not going across here, so there's a cold hole there. Okay, so we're getting a configuration of the ocean system. Antarctica ice. This is Arctic sea ice volume. Lots of really good animations here, and you can see what happens. So 2019, here we are here. This is the 1981 to 2000 average. Okay, this is temperature change 2014 to 2018 compared with 1880 to 1899. And look at the huge temperatures here up in the Arctic region. Also, you can see some of the, there's a relatively cold area here and much, much warmer temperatures here. So the Gulf Stream slowing down, doesn't curve as sharply. It overruns the continental shelf more, causing the heating there, higher sea level rise over these coastlines. And the hot water doesn't get across here, so this is colder than normal. You can see how warm Europe was here in 2014 to 2018. And you can see these regions warming up, and interesting pulse of warm water down here as well. Okay, one of the big signatures of warming is you get a lot of warming in the troposphere, the lower atmosphere. Okay, you can see the warming here going up greatly. This is with height going up, so warming up through the atmosphere. But because the long-wave radiation is coming up, it's being trapped by the greenhouse gases that are in this region. It's causing the tremendous heating in the troposphere. But when you go up to the stratosphere, there's less, the long-wave radiation is taken out. There's less coming up here to be absorbed, in this region. So the stratosphere is actually cooling. This is an important signature of the greenhouse gas effect. Methane is stalled over here, but it's rising, at very fast rates, but it was rising faster here. So, why is it suddenly, this is this slope here, but why is it suddenly doing this? Okay, this is 100 years of September sea ice, the concentration. Okay, and you can see, so 2017, you can just click on it to stop and look at specific years. So I'll see if I can be coordinated enough to stop it in 2007, which was an exceptionally low year up to that point. 2008 was low, didn't quite make 2007, missed 2012. You get the idea. You can have a look at it yourself. Extent from the reconstruction and then the data here. Okay, this is a very interesting animation looking at the changing position of the Hadley cell, rising and descending locations throughout the year. So the rising location of the Hadley cell is the blue. So look, so this is July, sun's in the northern hemisphere. Okay, so the Hadley cell is rising, not at the equator, it's shifted up here. This is what, 30 degrees, so this is maybe 7 degrees latitude or something. July, this is August. Okay, so it's rising here, it's descending here and descending here, but it's highly asymmetric. Most of the energy it's August, the sun's in this hemisphere, most of the rising is here, and then it descends mostly in the southern hemisphere. It also comes up this way and descends here, but to a much less extent. A lot more air moves into the other hemisphere. And then you can see how it shifts, how the curve shifts over time. Okay. August, September, October, December, January. Okay, I'm going to try to stop it over here. There. Okay, so the rising here is, this is about 10 or 12 degrees south latitude. The rise is strong here, and most of the air is moving. It's not symmetrically moving. Most of the air moves to the northern hemisphere and descends here. Okay, so you can tell a lot, you can get a lot of details about the Hadley cell, and that determines, where the jet streams are, where the Hadley meets the Farrell, and so on. Okay, this is a key image here. So this is very interesting and important. Although the Arctic sea ice extent, regions with at least 15% ice coverage area-wise, stalled out in mid-August to now, the volume of ice ties with 2012 for the record low. Recall 2012 set the record for minimum extent. Stay tuned for video. Well, this is the video, okay? So basically the volume of the ice is tracking at a record low, right, tracking on the 2012, but mid-August there was a disconnect in the extent. Okay, so what that means is that although the extent did not decrease anywhere near as quickly as it did in 2012, the thickness of the ice must have significantly decreased because the volume continued to decline as quickly as it did in 2012. Okay, so there's some interesting effects going on, and don't remember that to be counted in the extent, you have to have just 15% or more ice. Okay, so the ice, so basically the ice on the fringes of the pack in mid-August did not decrease significantly. So, that ice could have been 15%, and there could have been lots of reduction as you go into the ice pack. It could have been 50% ice and 50% water, and then that decreased to 15% or whatever, but it's still in the extent, so it's not really, doesn't change the extent value. You know what I'm saying? Like there's dynamic effects going on, but the volume is still tracking the record minimum volume, which is a key point.